Let us discuss another numerical example for continuous random variable in the case of multivariate case. Here it is given the joint probability density function. Let x, y, z be a trivariate random variable with joint probability density function given by this. So you can see that this is the joint probability density function. So then some of the questions are asked where a, b, c greater than 0 and k are constant, and then determine the value of k, find the marginal joint probability density function of x and y, and find the marginal probability density function of x. Are x, y and z independent? So let us write down this joint probability density function f of x, y, z. So here it is, this is the problem. The joint probability density function of x, y, z is given by f of x, y, z is equal to some constant into e to the power of ax minus plus by plus cz. So ax e to the power of minus of, let us see that, minus ax plus by plus cz minus ax plus by plus cz whenever x is greater than 0 less than infinity, y is greater than 0 less than infinity, z is greater than 0 less than infinity, and 0 otherwise. Where a, b, c are constant, a, b, c all are greater than 0 less than infinity, and k is also a constant, k is a constant. So now a, b, c are some given value, it can be any value, then this will be the probability density function. K we have to find out, k is a constant, we have to find out some particular value, a, b, c any value between 0 to infinity, it can be a probability density function, but for a particular values of k depending on the a, b, c, so it will be a probability density function. So how we can find this value? So because it is a probability density function, it has to be, it should satisfy some conditions. So one of the condition that it will be greater than equal to 0. So k has to be greater than equal to 0. K cannot be 0, then it will be all 0, but density function cannot be all 0. Then this integration, another property also it has to be satisfied. So it should satisfy another condition like that. So another condition is that integration if you do, so minus infinity to plus infinity, minus infinity to plus infinity, f of x, y, z, dx, dy, dz, this should be equal to 1. Now this density is 0 whenever x, y and z is negative value. So this is 0 plus this is only 0 to infinity, 0 to infinity, 0 to infinity, and this is k into e to the power of minus ax plus by plus cz dx, dy, dz. This will be is equal to 1. Now this is, now we will do the integration, which implies now you can see that suppose if you do integration with respect to x first only, so k into 0 to infinity, 0 to infinity with respect to c e to the power of minus by plus cz, these are independent of x. So then this will be e to the power of minus by plus cz, then 0 to infinity e to the power of minus x, integration just I am writing, e to the power of minus x minus of a, or we can write e to the power of minus a, and then this is 0 to infinity and 0 to infinity, then dy, dz, this should be equal to 1. So now this integration at x goes to infinity, then this is 0, at x goes to 0, then this value will be 1. So this is 1 by a. So which implies this is k by a into this remaining e to the power of minus by plus cz dy, dz, this is equal to 1. Now similarly I just e to the power of minus cz will be outside, e to the power of minus bi. Similarly you can see that it is nothing but k by ab e to the power of minus 0 to infinity e to the power of minus cz e to the power of minus cz dz. This should be is equal to 1, and then next this integration also similarly we will get, which implies k by abc into 1, this should be is equal to 1, which implies k should be is equal to abc. So hopefully you have understood it. It is very straightforward, that's why I did not do. So this is the first integration, e to the power of minus ax, similarly e to the power of minus by, then e to the power of minus cz, all will have similar by symmetry. These are very similar, just the constant variables and constant are changed. Accordingly, this value will be coming out 1 by abc will get. So k will be is equal to 1 by abc, abc. So k by abc is equal to 1. So hence k is equal to abc. So hence our density function, it is known to us now. This is nothing but it is equal to 1 by abc. K is equal to abc here. So this is abc into e to the power of minus ax plus by plus cz. So this is the constant k is equal to abc we found. Now next question is that determine the value of k, we have already found. Find the marginal joint probability density function of x and y. So any subset of this random variable is a marginal, we say. So because there are three random variable x, y, z, so we want to find the marginal probability density function. So the marginal probability joint probability density function of x and y, y and z, it is asked x and y, So marginal probability density function for joint probability density function of x and y is given by, so f of xy. So you can remember that how we can find the marginal probability density function. So those variable we want to keep, the remaining variable there is only z, minus into plus infinity, f of xy z, the joint probability density function we have to integrate with respect to the remaining variable, here it is z. So f of xy z. So now this f of xyz, this value we know here, this is equal to, this is equal to, we just find out, okay, this is other problem, okay, here actually. So the marginal probability joint, so we have already found out, this is the joint probability density function f of xyz. So we, because it is equal to this value whenever these are all greater than 0, otherwise this is 0, hence this is equal to 0 plus this value 0 to infinity, then abc e to the power of minus ax plus by plus cz dz. So then we have to do the integration. abc is a constant. Not only that, since it is a, we are doing the integration with respect to z, so e to the power of ax plus by, it will be outside this integration, into 0 to infinity e to the power of minus cz dz. So then if you take this integration abc e to the power of minus ax plus by, then if you do the integration minus cz by minus c 0 to infinity, so because as z goes to infinity, again this is same, it is becoming 0, then 1 by this is 1, z goes to 0, this is 1 by c. So this is abc and c cancelled, so this is ab into e to the power of minus ax plus by. So note that this value, this is value if it is true whenever x is greater than 0 less than infinity and y is greater than 0 less than infinity, then we can write this value. So this is actually here. So if this condition, so we can write like this is if x is greater than 0 less than infinity and y is greater than 0 less than infinity. Otherwise, if it does not satisfy, then this will be 0. So that's why this is equal to 0 in otherwise. So this will be, we complete, we have to write, just we have find out this value for whenever. So you can write like this: if x is greater than 0 less than infinity and y is greater than 0 less than infinity, then we find this value finally. So then this is BC, AB into e to the power of minus ax plus by. So then we can, so this is up to this. So hence f of the xy of xy can be represented by this relation ab e to the power of minus x plus by if x is greater than 0 less than infinity and y is also greater than 0 less than infinity and 0 otherwise. So this is the marginal joint probability density function of xy we found. So this was the question. So next question is that find the marginal probability density function of x. So similarly we can find the marginal probability density function of x. So the marginal probability density function, the marginal probability density function of x is given by f of x of x. This is equal to, so note that we want to keep this variable, so remaining variable we have to do the integration minus infinity to plus infinity minus infinity to plus infinity fxy xy, so xyz we want to keep x, so dy dz. Now if x between 0 to infinity, then this value is equal to this is 0 plus 0 to infinity and 0 to infinity. This value is like earlier abc e to the power of minus ax plus by plus cz dy dz, because you want to keep x, so dy dz. So very similarly we can do the integration. Earlier we do that. This will be abc into, see that e to the power of minus abc into e to the power of minus ax will be outside and minus by plus cz integration. If you do, you can check that very similarly it is 1 by b into 1 by c will find, and this b c it will be cancelled, a into e to the power of minus x. So we can write the marginal probability density function of x is given by f of x is equal to a e to the power of minus ax whenever x is greater than 0 less than infinity, 0 otherwise. So this is the marginal probability density function of x. So similarly you can find marginal probability density function of y and z very similarly by symmetry we can say that. So similarly we can find the marginal probability density function of y is f of y e to the power of, so b e to the power of minus by whenever y is greater than 0 less than infinity, 0 otherwise, 0 otherwise, and the marginal probability density function of z is c e to the power of minus cz, 0 less than z greater than 0 less than infinity, 0 otherwise. So why we found that? Because in the next question it is asked whether x, y and z are independent. So find the marginal probability of density function of x we have found, find the marginal joint probability density function of x and y, that also we found. Are x, y and z are independent, x, y, z. So how we can say that? By definition, if you can see that the joint probability density function can be represented as they are product of marginal probability density functions, then we can say that they are independent random variables. So here we can see that f of x, y, z, so that is nothing but abc into e to the power of minus ax plus by plus cz. Whenever x is greater than 0 less than infinity, y is greater than 0 less than infinity, z is greater than 0 less than infinity, 0 otherwise. Now if you multiply this fxx, fyy and fzz, so then you can see that, so see that this will be also same, abc into e to the power of minus ax plus by plus cz, because whenever x is greater than 0 less than infinity, y is greater than 0 less than infinitive, and z is greater than 0 less than infinitive. So if we multiply, then you will get that. Otherwise, this value is 0 otherwise. So here also you can see that this is equal to dx for all xi. Hence we can say that f of x, y, z is fxx, fyy, fzz for all xyz belongs to R3. So hence which implies that x, y and z are independent random variables. Independent random variables. So this is the last question we did it. So then I hope you have understood by these numerical examples how multivariate random variables, when it will be defined as the independent random variables, how to check that, what are the properties, what are the properties of the joint probability density function, because here we can using the properties only we found the values of k, how to find the some of the probabilities. So here we found that some of the probability for discrete case. For continuous case also we found probability z greater than or equal to xi using joint probability density function. So we have, hopefully you have understood this. Next we will discuss some of the special distribution functions in the multivariate random variable case. So we already discussed for univariate cases some of the discrete random variables in explicitly like for example Poisson random variables, binomial random variable, Bernoulli random variables. Then in the continuous cases, uniform random variables, exponential random variables, gamma distributions, normal distributions, all we discussed. Here we will discuss one discrete random variable in the multivariate cases and one continuous random variable in the multivariate cases we will discuss.